We're going on to topic 6 of chapter 1, which is subtracting real numbers. And we're on page 43 in the textbook. Now, as you look at this example here, 9 minus 7. This is the traditional subtraction, and we get a 2. But in algebra, we often think of trying to convert a subtraction to an addition problem, and we do so by putting the negative 7 in parentheses and just putting a plus there. So notice what we did. This is subtraction. This is addition. And we can change any subtraction to an addition, in this case, of unlike sign numbers. So keep that in mind. So in a sense, this is a negative 13 plus a negative 4. This is going to give you a negative 17. Now here we have the opposite of a negative 6. That's going to give you a positive 6. So even though this is subtraction, your answer is a positive 11. Because we're saying this, instead of being a subtraction, we're using the term the opposite of. That's what changes this to a plus. And again, we're going to use the rules. This is the larger absolute value. The smaller absolute value, we're going to subtract the 2, get a 3, use the sign of the larger absolute value. Again, if you're putting that into your calculator, you're going to get this. Now, another little hint I might introduce at this time is that when you see the opposite of a negative, you can just make them a positive. So this is going to be a 7 minus 1, larger absolute value, smaller absolute value, gives us a 6, and we use the sign of a larger absolute value. Okay, now the key to all of this, the opposite of a negative is a positive. All right, continuing as we go into some of these examples. Here, they're asking us, and let me sure I copy that down correctly there. There's a negative sign in there, okay. So, once again, if we see the opposite of a negative, we can just jump right in there and make that a positive. So, we're just adding 2 positives, so that gives us a 9.9. Here we're subtracting 2 negatives, so we could think of this as a plus, but it's going to be a negative 3, negative 5 over the common denominator. That'll be negative 8 over 10. I think we had one like this. Reduce that, 4/5. Here again, we have the opposite of a negative, so we can make that plus, but we're going to need a common denominator. That'll be 15. So multiply that by 5. 3, 3. This is going to be a negative 10 plus 12 over 15. This will give us eventually a 2/15. Now, as we go on to example 3, again, you're going to come across some like this, so you want to be sure to know how to handle it. Here it's saying subtract 8 from a negative 4. So my suggestion is just convert this to what it is. Subtract 8. negative 8 from a negative 4. That's going to give you a negative 12. Now, what you might have done in the past, from a negative 4, you could have put here. That's your first term in a sense. Subtract 8 from it. So it gives you a negative 12 either way. But these can be tricky, so you have to look at them carefully. All right, going on to some more, a little more complex examples, but again, you're looking for a strategy. In example 4, the opposite of a negative we know is going to be a positive. And a strategy might be add these two together. That's going to give you a negative 22. And add these together. This gives you a positive 16 now. And then your answer is going to be negative, but you're going to subtract 16 from 22 and get a 6. So negative 6 for that one. Here again, two negatives will make that a positive. So this becomes an 11.9 minus 5.6. It didn't come out too clear. And here we can just do a little subtraction. This is going to be a 3, and this is going to be a 6. So 3.6 for this one. Now in example 5, they're using grouping symbols. So again, this is going to be a negative 7 and a negative 2. We'll make this a negative 9. So we have a negative 3 and a negative 9 gives me a negative 12. This one, order of operations, exponents, 2 to the third power is going to be 8, and grouping symbols. This becomes a positive 10 outside the absolute value, so that's a negative 10 there. This is going to be the opposite of a negative 5, makes it a positive 5. So what's in this bracket is a negative 1. So here we have a negative 11 and a positive 8 gives us a negative 3. Now in example 6, they want us to replace the variable with a known quantity. So we have to do some substitution. So our x is going to be a 2. Now keep in mind our y goes in there as a negative 5. That's what y is. So it's the opposite, because this sign is there. The opposite of a negative 5 makes this a plus 5 over 12 plus 2 is going, this is a 2 here, so this is a 14. So we have 7 over 14 equals 1/2. And again, I cut a little bit on this. I don't want the tape to be too long. This is all in your textbook, of course. Now here, x squared is going to be 2 squared. That will give us a 4. Minus 3. Now our y, remember, put that in a parenthesis. Our y is a negative 5. So, negative 3 times negative 5, that is 2 negatives, this becomes a positive. And we multiply that, that becomes a 15. 15 plus 4 is 19. And again, you'll have practice and then your quiz me's to see if you've mastered these skills. And the only way to do it is to do the practice. All right, in this next one, we're going to have a little geography lesson. Here's Mount McKinley, which is somewhere, and its elevation is 20,320 feet. And then in California, somewhere, we have what is called the Death Valley. Death Valley is actually below sea level. So if the sea were ever to get there, it would flood it. And we won't go into climate change or anything right now, but how do you find change in elevation? Well, usually what we do is we subtract the numbers. So that'll be 20, 320, minus, but keep in mind now this is a negative number, and we want to find out what our answer is. So we want to find, in a sense, the distance between this top point here and that bottom point there. So in essence, we're taking this and adding it to this number, even though it looks like subtraction. Because we're taking the opposite of a negative, we actually add that. So this becomes then, so adding these two numbers then, we end up with the total distance from the top of Mount McKinley to the bottom of Death Valley is 20,602 feet. Okay, for our last topic today, we're going to do finding complementary and supplementary angles. And for this, we just need to know a little definition. A complementary angle is the sum of which are 90. Would be, if this were, let's say, 60, then this one would be 30. So the complementary angle would be whatever's needed to make it 90. So for in this case, this is example A of 8. If we had 36, we'd subtract the 36 from 90 and get 54, I believe. And we put a little degree sign. So if we added that up, that would be 90. Now, for supplementary angles, their sum is 180. So if this angle were 62, and for part B, the supplement of this, mentally I was thinking if this were 60, a supplement would be 120, so 2 less, this would be 118. So just for definitions, and a way to remember these is complement comes early in the alphabet with the letter C. That's the smaller one. Supplement comes further in the alphabet with the letter S. That's the larger one. So complementary angles are 90, supplementary 180. By the way, this is called a straight angle. And it would be like half of a circle is 180. All right, good luck. We have, I believe, a few more topics to Chapter 1. We'll do those the next time.